Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions.
We are very excited to host today's event, Master Machine Learning Projects with Google Cloud. Our presenting today's topic is Imran Ahmad. Imran Ahmad is a data scientist, author, and cloud instructor with extensive experience in designing, implementing, and optimizing intelligent algorithms. He has a passion for simplifying complex technologies, making them accessible to learners and professionals alike. As an AWS authorized instructor and Google Cloud authorized trainer, Imran specializes in delivering impactful training sessions that enable professionals to master cloud computing and data science concepts. His passion lies in teaching and creating innovative solutions that solve real-world problems and drive measurable value.
Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges.
We have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the AI and data practice areas.
Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com.
Today's session will uncover the best practices to transform business challenges into cloud-driven solutions. In addition, participants will gain practical insights through essential concepts and practical demonstrations to elevate your cloud experience.
Now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic.
Hi, Imran. Thank you so much for joining us today.
Okay, good morning, good evening, wherever you are. So welcome to our masterclass on Google Cloud. And as you know that Google Cloud is a very powerful tool. And in this presentation, what we'll be doing is that we'll be looking into 2 or 3 different aspects. What is the data dimension of this tool? What is the compute dimension of this tool? Which packages are there? Which services are there? In total, about 200 of them that helps us creating, solving solutions for any problem, large scale problems. And welcome to this class. My name is Imran Ahmed, and I am an authorized Google trainer teaching Google for the last almost 8-9 years now. And I did PhD from in machine learning about 13 years ago. And the reference is right here to my LinkedIn profile. You're more than welcome to look into this. Let's look into that, what we are going to cover in today's presentation. So first of all, when we talk about Google Cloud, as I mentioned, it is a bunch of APIs. It's a bunch of services that allows us to create some really powerful infrastructures. And if you want to look into the solutions that it allows us to create. So first thing that comes into our mind is that how we are going to first of all choose the services. This is what we will be looking at, and we'll also look into the if you look into the Google console. As I mentioned, it's a bunch of different services that are there. And once you log in into Google Console, there are two ways that you can navigate and find way across those services. First way is that you go here. Now this tells us all the services that are available in data and compute dimension, or you can just write the name of the service here, and that will take us to the service that you want to use. So we'll start with presentation with looking into the digital transformation that can potentially happen using this very powerful tool. So let's start with this, and let's see that what potential we have in using Google Cloud in that direction, in that dimension. So we'll start with this one. Then we will looking into the data dimension. We'll see that how we can do data transformation. We are talking about large-scale data transformation, storing data, processing it, building ETL pipelines that are elastic in nature. And then, so this is the second part of this presentation. Then we will look into how we can create some innovative solutions that are not possible on-premise environment, So, and then we will look into some modern infrastructure and applications. And finally, we will talk about the trust and security part of it. So when we talk about I said that Google Cloud is a disruptive technology. This is one of those technologies that has potential to create some really powerful solutions. And it means that when we talk about the cloud itself, as we know that we keep on hearing about cloud, but what exactly is cloud? So it's not that simple to define in simple words, but the best way of defining cloud is that this is on-demand computing resources and services. They are created on demand, and what they provide you with is that they provide you with a bunch of services that you can just use and in the projects that you have. So this is the best way you define the cloud itself. Now we talk about cloud native services. What are cloud native services, right? Now, cloud native services are the services that are created for the cloud. So it means that if you are already using a database like SQL database, and now that database, if you want to move to the cloud, now, for example, you have Oracle, you're using Oracle, and you want to move to the cloud. Now, Oracle is not a cloud native technology. It was not created for the cloud. It was created for the on-premise infrastructure, but now we are trying to use it in the cloud. So we define cloud native as those services that are created for the cloud. So they are built specifically to take full advantage of the cloud. Then digital transformation is using cloud native services, and sometimes other services as well, traditional services, on-premise services, to create solutions that can solve a large-scale problem. So if we can do that, then what is the criteria of success? How do we know that the solution that we are making, this is going in the right direction? So for that, what we have is that we have different metrics that we can use to quantify the criteria of success, whether it's a successful project or not. So we measure that in terms of cost. We measure that in terms of performance. We measure that how successful our implementation is in terms of our ability to port and use most of the services that we were using in on-premise, right? And it's also about that when we move to the cloud, one defining feature is that it is on-demand services, and it means that you have operational expenditures, that is OpEx, instead of CapEx, that upfront expenses that in on-premise environment you need to purchase the equipment, and so this is one of the differentiating factor, and that is why cloud technologies, it allows you by nature, it allows you to innovate, and it allows you to innovate because what's there is that it's more flexible. This flexibility is one of the defining features of the cloud. When we say that so this it is flexible, so you see that this flexibility that it has. Now this is one of the defining features of the cloud. Now if you look into that how cloud is transforming business, first of all, cloud allows you to make scalable infrastructures, and by scalability we mean is that you have a choice. You can start with some simple architecture, some simple machines, a small number of machines, and as your problem goes more and more complex, so you can increase the resources over time. It allows, this is the fundamental flexibility that is there, and whatever we are creating, it follows the security best practices. It is everything is authenticated, it's authorized, data confidentiality is implemented, data non-repudiation, data integrity, all 5 principles that we have for secure infrastructures that are there. So whatever we are creating cloud solutions based on the best practices. And then what we do here is that because it's scalable, it means that you only use the resources that you need. It creates solutions that are cost effective. They are cost effective and powerful at the same time, because you use those resources only when they are needed. So this pay as you go, this allows you to innovate, and it allows you to create flexible infrastructures. Now, if you don't adopt a cloud, so there is it means that you are still stuck in those inflexible environment where it's hard to scale up and down. So now, as I mentioned, this scalability is one of the defining features. And when we talk about the cloud infrastructures themselves, so the cloud can be public cloud like Google. Then you will see that they are private clouds. Now, private clouds are that if you have, for example, if you're a bank or if you are a government and your data is sensitive, by regulation, it cannot be on a public cloud. In that case, what you can do is that there is a way you can implement private cloud that provides services on the data that is stored on your on-premise environment. That's by definition what public cloud is. So it means that it's secured within the walls of your own infrastructure. And sometimes what we can do is that we can combine these two together. So you have whatever is on your, so if you combine these two together, then combination of these two create this multi-cloud environment, right? And it creates hybrid clouds. No, sorry, multi-cloud is something different. So it creates this hybrid cloud. Now, hybrid cloud is where we have defined, where we have combined both the public and private cloud. So if you combine, so it means that whatever you can put that in the cloud, in the public cloud, you will put it there, and whatever you cannot, you will place that, you will keep that on premise, and that creates basically hybrid cloud that is there. Now, multi-cloud is a concept that sometimes there are services that are available in AWS, sometimes there are services that are available in Azure, sometimes there are services that are available in Google. For example, there are some machine learning algorithms that are only available in Google. And there are some services, for example, there is a database that is Ledger. Ledger database is used in transactional systems, and now that is only available in AWS, or there may be some other dependencies on more than one cloud. In that case, if your solution is using more than one cloud, AWS, Azure, and Google, so we call that as multi-cloud. So if you are developing a solution for multi-cloud environment, in that case, what you have to do is that you have to choose services that are not vendor specific. So you have to choose services that are platform independent. It means that you can choose services that are mostly based on either Docker-based virtualization, you virtualize services, or VMs, and you don't select something that, for example, we talked about cloud native solutions. So cloud native solutions that are right here. So these cloud native solutions, they are usually vendor specific. So if you're looking for multi-cloud environment, so what you will do is that you will choose those services that are not vendor specific, because you need that flexibility to move from one cloud to the other without tying in into a specific vendor. So now these are the different, now if you look into the different drivers and challenges of digital transformations, first of all, what is the driver? Why you will move to the digital cloud? What's the reason? So the driver, the force of digital transformation is, first of all, customer wants improvement in terms of performance. They don't care what you're using. They do not want their websites to wait for a couple of minutes. They want instant services like this. And then if you are looking into decision making, now data driven decision making, those dashboards that we have, live dashboards, they require elastic infrastructure that has enough computing power that can process the data in real time, so that those decisions can be made in time. For certain use cases, for example, stock markets, or there are certain issues related to government where the real-time data is important. So in that case, you need to have that processing infrastructure that can process the data in real time. Now, there are challenges there as well. So sometimes there are legacy systems, and for example, my full-time job is with Canadian federal government, and we have Netezza, IBM Netezza. Now, IBM Netezza or So it means that the data, huge amount of data that is in IBM Netezza. Now we have dependency that if as we move towards the cloud, so we need to find a solution to build that bridge between IBM Netezza and the public cloud that we have, and how we are going to integrate that. So this is a challenge that we have. Now, if people are not used to cloud, because cloud comes with a slightly different sets of IDEs, integrated development environments. It's on-demand services. So there needs to be a philosophical shift within the way you approach a problem. So it may happen that you may have this cultural resistance or lack of skills, for example. So that may be one of the issues. Then, if cloud is not used in the right way, it will create solutions that are, instead of bringing the cost down, they will be more expensive, and it will bring more complexity. That's why you need to look into the best practices when you are creating solutions for the cloud. Always looks into the best practices. Look into the design patterns. So there are certain well-established cloud design patterns like ephemeral compute dimension. Then there is looking into load balancing. So I'll talk about that later towards the end of this presentation. Now, if you look into the fundamental concepts of the cloud, first of all, we talked about that when we move to the cloud, essentially what we're doing is that it's a shift from upfront capex expenditures. The usual way what you do is that you spend $100,000, $200,000 buying equipment. Then you try this out. If this is not the optimal solution, then what you have to do is that you have to perhaps adjust that, and you don't know that should you buy for the peak requirement, and should you buy for the average requirements. In any case, that's the our usual traditional philosophy, that we always have that capex. Now, as we move to the cloud, essentially you are moving towards service-based infrastructure. You provision something, you provision resources if they're good for you, if this is what you want, if the size is right for you, you continue. Otherwise, you can just unsubscribe, and you don't have to. You are not. There's no long-term commitment. So now you can say that, okay, what's the advantage of that? Advantage of this is that this allows you to have innovation, because experimentation depends on experimentation, your ability to experiment. Okay, let's try a BigQuery. Let's try Fusion. Let's try Vertex AI. So all of this, unless and until you have ability to try out your idea and choose among the ideas that is best, you won't be able to innovate. So cloud environment is a catalyst. It's a catalyst. This is an enabler for innovation. Now, now, whether you choose private, hybrid, or multi-cloud, it depends on the factors. For example, what is the regulatory requirement? And it also depends on whether you are dealing with any data sensitive workloads. Data sensitive, that is classified data, for example. And when you are looking into hybrid cloud, essentially what you are doing is that you have chosen to put in the cloud whatever is not classified, whatever is not sensitive, and you enjoy the best of the both worlds. But it also increases the complexity. So now, if you talk about the Google's infrastructure, now Google infrastructure, it owns and operates data centers worldwide. So if you look into the diagram, what we have is that you will see that there is Google Cloud is located across the globe in strategic locations. So Google owns and operates data centers that are worldwide, and Google is the only company that entirely owns the high fiber private network backbones. Once you're in the Google Cloud, you do not have to travel to the internet. Google owns this private network backbones 100%. And there is reliability and security at scale. That's the implication of that. Now, if you look into the computing models, we looked into the cloud models. Now, first thing that what you do is that when you move to the cloud, you start thinking about that how we are going to design, how we are going to architect our computing infrastructure. So first thing that comes to your mind is that whatever, for example, if I have a laptop and if I have a desktop, that laptop and desktop, if you start using in the cloud, can we just virtualize that and use it with all the apps and all the software that is there running there? So that is sort of leading us towards infrastructure as a service. So you are looking a virtualized laptop in the cloud, or you are looking for a virtualized desktop in the cloud, or you're looking for a virtualized cluster in the cloud. So you are trying to virtualize the infrastructure. So that is our first approach of creating this computing model. Now, the second one would be, in that case, what we'll be doing is that we will be responsible for managing operating system, because just like in our laptop we will do. So we have just moved to the cloud. So our responsibilities remains unchanged. And so this is first approach. The second approach is that we can we can virtualize the platform. What platform means is that if you are, for example, using Jupyter Hub to develop the code, or you're using an IDE. Now that IDE, integrated development environment, whatever you are using to develop the code. So if you want to virtualize that IDE, if you want to virtualize that Jupyter Hub, so that is basically the platform as a service. Another example would be that if you are in, for example, video editing. So Final Cut Pro, because video and photography is my passion. So if you're in video editing, Final Cut Pro, if you use that in the Mac, if the cloud can provide the virtualized version of Final Cut Pro. Now, Final Cut Pro is a platform to edit video, and it's not the end product. It's a platform that is provided to you to create the end product that will be the end video. IDE, Jupyter Hub, for example, it's not the end product. It's a platform that is provided to me to develop the code. And if we can virtualize that platform, then that is platform as a service. So we have infrastructure as a service. First approach, we virtualize the infrastructure. Platform as a service, in which what we do is that we virtualize the platform. In the second one is SaaS, we'll use virtualize the software like Gmail and Google Workspace. That's the example of that. So these are the three ways that you can virtualize. You can virtualize the computing infrastructure. So you can think about this, that what is your solution? Infrastructure as a service, platform as a service, or SaaS, that is software as a service. Now, infrastructure as a service, whatever works on premise, it will work there. But it also means that there will be more management that is required. And it also means that you have to choose the size of the hardware. What is the RAM? What is the size of the CPU? Which CPU you will be using? So all of that needs to be there. Then a platform as a service, less overheads, but now you have chosen to choose a virtualized Jupyter Hub, and the service provider will choose the hardware for you. What is the CPU? What is how much RAM is needed to run that Jupyter Hub? So it means that there is lesser control. SaaS as a service, but it means that if software as a service, when you use Gmail, for example, you have no idea that what is the RAM that you are using, so you have no idea over that, and you have in fact no control over that as well. So it means that if you want to, so it depends. That it will depend on your needs. That if you are using SaaS, then it means that you are looking for a managed solution, but you have lesser control there as well. Now, there is a shared responsibility model when we talk about cloud. Shared responsibility model is that it defines that what is now Google is the provider and you are the customer. So let's first look into the roles that we have when you're using the cloud. So now provider is the Google and customer is the user, that in this case is you. And now if you look into in this aspect, what's there is that Google has the responsibility to provide you with the physical security, with underlying infrastructure, with network, with virtualization that Google said that they own, but it means that you don't have access to it, so they need to provide you with that. It's your responsibility to use it. You need to, of course, provide the data and the configurations, and this is your responsibility. It's like, if someone builds a home for you, so they provide you with doors, they provide you with windows, they provide you with locks, and it's your responsibility to use those locks. So if you go for a vacation and unfortunately if there is an incident that happens and your things are taken away, they got stolen, it's you. So we have to, when we're investigating, we have to foresee that whether the locks that were provided, they were strong enough or not. If they were not, that was the house builder's responsibility. In this case, that will be the Google responsibility. If the locks were there and you did not use it properly, then it was your responsibility. So that's why this shared responsibility model, this is one of the fundamentals of providing you or defining that what is your responsibility and what is essentially Google's responsibility. So, and this is something that we use extensively. We use that to look at the scope, that what the scope of responsibility, it defines that. Now, if you look into the data, now the modern solutions, they are all data driven. We talked about compute, but now let's talk about the role of the data in this. So now data is something that has information, that is the representation of some physical phenomenon. So data is something that generates business insights. It guides the data-driven decisions, and it creates opportunities for products and services. But data is defined by three things: volume, velocity, and variety. How much is the volume? How much is the velocity? How fast it is changing? And how many different types of data is there? Volume, velocity, and variety. Now, when you are in the compute, we talked about different types of infrastructures, infrastructure as a service, platform as a service, software as a service. In data, your choice is that what sort of data repository will be optimal for you. In that case, what we're looking for is that, for example, are you going with database? If you're going with database, then what type of database you will be using? You will be using structured database. Structured database is used for structured data. It depends what type of data do you have. Or you are going for data warehouse or data lakes. So I want you to think a minute about the difference between data lake and data warehouse. And these are the important ideas in the data dimensions, important concepts, the difference between data lake and data warehouse. So data lake is where we store unstructured, semi-structured data. We don't have the ownership of the data. It is basically used for analytical purposes. You mess up with that data, there is no process that is dependent on that. It's for your experimentation. And it means that data lake is the input to your machine learning model. This is where you create insights. Data warehouse, on the other hand, this is your operational repository. There is a process, there's a critical process that is dependent on data warehouse. You can use the data, but this is more transactional. So this is these are so there is data warehouse, database, and data lakes, and now, because data has values, so it's all about creating values from this data. We need to process this in the right way. We need to look into that what is the signal, and we need to filter the noise. So in that case, for example, I talked about the volume, velocity, and variety of the data right here. Now this volume, it depends that your solution, your choice of the solution, it will depend that what is the data volume, and what data volume now, and what are the future needs. What is the velocity of the data? Is data changing fast? And for that, for example, if it's an IoT device, have very specific patterns. First of all, the data that IoT devices have, now that data size is not that huge. If this is a sensor, if it's a sensor network, the amount of the size of the data that is there, that will not be huge, but its velocity will be huge. It means that we have to create solutions that can deal with that real-time data. Then when we talk about all data types, so all data types includes structured data types and unstructured data types. Now, if we want to draw this, what we have is that the data that we have, you can divide that in different parts. Data, it can be structured, or it can be unstructured. When it's unstructured, it can be text data, or it can be multimedia data. Now, these different types of data that we have, now these are all different types of data that we have. Now, we need to find a way to store them in the cloud. And once we store them in the cloud, we want to make sure that there is data quality, we have security of the data as well, and it is under the regulatory compliance that is needed to build the solutions around that. So we need to make sure that we are following all the regulatory requirements, and the data that we have, that is stored in a secured way as well. Now, if you talk about the Google specific solutions, so in that case, what we have is that now the simplest way is to store the data in Google Cloud Storage. That is the object storage. The object storage is the simplest way of storing the data, but object storage is the simplest way of creating. We talked about data lake, and when we want to create the data lake, object storage is the simplest way to create the data lake in Google Cloud. And in that data lake, we will have images, we will have media, we will have backups. And when we store the data in data lake, it will you can define how long will it will be stored, and based on that we have different classes: standard, nearline, core line, or archive, based on what is your read and write patterns. If you are not reading it that often, once a month, then you can save some cost by moving it to in a class that is nearline. So that will save you some money. If you are reading the data once 3 months, that is your read patterns, then you can move that to cold line. And if you are reading it, you are expected to read it once a year. In that case, you will move to the archive. So these are the different storage classes that we have based on our reading frequency, expected reading frequency. So in that case, it will help you saving some money. So when we talk about different solutions that are available for Google Cloud, the simplest of them is SQL, Cloud SQL. This is essentially your traditional relational database. If you want to create that in the cloud, you will choose Cloud SQL, and there are different flavors of Cloud SQL that is there. You can choose that in MySQL, or you can choose that in PostgreSQL, or you can choose that, create that in SQL Server. These are all the different flavors that you have in Cloud SQL. If you are looking for a managed structured database, in that case, you can choose Cloud Spanner. Now, Cloud Spanner is gigantic. It's huge. Cloud Spanner is that what runs Gmail. So it is of the scale of internet. It's horizontal scalable, and it's of the global scale, but it's also expensive. And these two, essentially, they are your relational databases. You know, this 1 and 2, both of them are relational databases. So both of them are relational databases. If you're looking for a non-relational database, then Cloud Bigtable, that is perhaps your best option that we have. In Bigtable, now Bigtable stores the data in a different form. It stores the value in a key value pairs, and it is a wide column. Here, when we talked about, for example, these IoT devices, now these IoT devices, if you have this streaming data, you want to store that in Google Cloud, then in that case, the solution that we have is Bigtable. Bigtable because the data that is coming from these IoT devices, it won't be structured data. This data will not have structure, and if you want to, the velocity will be huge. Volume depends on the size of the sensor networks and the sensor devices in this example. In that case, what we can do is that we can choose Cloud Bigtable, because for that sensor network, SQL and Spanner, they won't be able to meet the needs. So let's see what we discussed. So we discussed the compute dimension. In compute dimension, we said that there are you have infrastructure as a service, platform as a service, and software as a service. This is the fundamental decision that you have to choose, that how you are going to approach it. And then what you have is that once you have taken that part, you have chosen that, then you will choose that whether you want to go with how you are going to. Let's just assume that you have chosen infrastructure as a service. Then it has other implications as well. So I started this presentation with talking about uh, need to first figure this out here, that whether you are looking for uh, here cloud native solution or not, right? So I introduced the term that is cloud native. Now, when we talk about cloud native, platform as a service will almost always be cloud native, because you have chosen to pick a platform that is hosted by the cloud. What is the example of cloud native in Google Cloud? The example of cloud native is BigQuery. Now, BigQuery is a platform. It's a platform that is provided to you, using which you can process SQL query, but the hardware of that is managed by Google itself. So these are the implications that are there. So now this is the compute dimension. If you're looking into the data dimension, then you have to first of all characterize the data, look at the volume, velocity, and variety that I have right here. And based on that, you will see that whether you need a database, whether you need a data warehouse, or whether you need a database, data warehouse, and data lake. And if you need more than of these components to store the data, we call it polyglot persistence. There's a term that we use. Polyglot persistence is what we say when we need more than one database and data lake, database and data warehouse, or database, warehouse, and data lake. We call it as polyglot persistence because our system is the data of our system. It has high velocity data, it has high volume data, it has high variety data, and that is why we need to have polyglot persistence to meet the need of our system. Now, if any questions so far? And no questions? Okay. Now, let's now look into some other tools that are there in Google Cloud. So first we have Firestore, and then there is BigQuery. So I talked about BigQuery. BigQuery is massive in Google Cloud. So if you look into BigQuery, now BigQuery in many ways is perhaps the most powerful tool that Google has to offer. And let me show you what I mean by that. So when we talk about BigQuery, okay, let me go to Google Console. Okay, so if you go to BigQuery, now BigQuery is somewhere you can just write a statement here. You can write a query here, SQL query here, and you can just run it. And now as you will see that as you will run this query, you are not sort of writing any, you are not choosing the hardware, you are not choosing the any software that is there. So if I say that select, now as I'm writing this query, you will see here that I am because I'm not choosing any hardware, so I am leaving it to the Google Cloud, that how it chooses that, right? Now, as you will see here, that BigQuery is a serverless data warehouse. And what it means is that out of the three types that we said, this one is, first of all, it's platform as a service. The reason is that it gives us a platform to develop a query, right? So this is what it's doing. So what it does is that it allows us, this is a platform for us to write a query here. So for example, so if I want to write something here, so if okay, first of all, let's go to BigQuery. So the query that I can write, I need to enable it first. And once I enable that, okay, yeah. So you can write any query. Let's say that I write this is a query that I've written. So what I'm saying here is that select product ID, some give me quantity into price, it will give me the total sales. And what I'll do here is that it will give me the transactions, and I'm looking now, whatever I'm writing here, I am not choosing any hardware to it. And that is why this is a classical example of platform as a service. This is one thing. The second thing is that it is vendor specific. It means that whatever we are writing here, it is specific to Google. We cannot run that on AWS. That's the thing. The third thing is that this is serverless. Now, serverless is a term that we use if it's almost a misnomer. Serverless does not mean that it does not have a server. What it means is that we are not responsible of managing this server. Yes, there's a server, but we will not be managing that server. So that's why it's called serverless. Then it can handle large data sets very quickly. That's the defining feature of BigQuery. Now, it can integrate with multi-cloud data sources. You can import the data, only data you can, yes, you can import the data, but the code that you will be writing on BigQuery, it may not be 100% transferable, portable to other systems. Now, so this is how you pick your battles. You see that, okay, for this this problem, we need infrastructure as a service? In that case, you will have to manage the server. If you want managed solutions, it will be platform as a service, not serverless, but now it's not platform independent. It is elastic, but it's not platform independent. So you have to see that what is the optimal solution.
Let's take a quick 5-minute break, and then I'll start on the remaining topics after the break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off.
Now, if the first thing, the most usual scenario is about the database migration. Usually people have databases that are already in on-premise environment. Now, the thing is that when you move to the cloud, the approach is called lift and shift. Lift and shift is a design approach where we choose the components in the cloud in a way that can run whatever we are running on premise. We do not want to redesign. We do not want to refactor. We want whatever is on premise, we want that to run on the cloud. That is called lift and shift approach. So we choose those components that map to our on-premise environment. Is there anyone who can think about what is the disadvantage of this approach? Anything that comes to your mind? The disadvantage to lift and shift is that yes, you do not have to rewrite, but you do not take full advantage of the cloud. So the opposite to that approach is the cloud native component. So either you choose lift and shift components or you use cloud native. Now, cloud native are the ones that are created for the cloud. Now, cloud native are the ones that are created for the cloud, and what it means is that they allow you to take full advantage of the cloud, right? So these are the cloud native components, right? Now, you can have lift and shift components or you can have cloud native. And we talked about the trade-offs that are involved. Lift and shift, you don't have to redesign, but you do not take 100% advantage of the cloud. Cloud native, now you take 100% advantage of the cloud. Those components, those softwares, they are not afterthought. They are written for the cloud era. But it means that there is no equivalent of that on premise. So you have to design from the scratch. So that's the thing, right? Now, if so this is the migration approach. Now you can migrate to the managed services like Cloud SQL or Spanner. And now, if you want to move to the cloud, even if you try lift and shift approach, still you will get benefits because now you are not responsible for managing the hardware. We talked about the responsibility model, shared responsibility model. So it means that the hardware, the networking, the database patches, all the operating system, all of that is taken care by the vendor. Even if it's lift and shift, even if you are just running Oracle, so you have not chosen cloud native, still you will get lots of benefit out of that. Now, once the data is there, now you not need to process it. You need to choose tools. You need to see that how you can get. So that is called, this whole thing is called descriptive analytics. You want to describe whatever is in the data. Data is in the cloud. And for that, you want to use different BI tools that are available. And now that descriptive analytics, that is called business intelligence. You want to bring that analytical skills to the cloud. In that case, so the BigQuery is a great tool for analytics. So you process the data in BigQuery, and straight from the BigQuery, it can go to a free tool that is called Looker Studio. It's used to call Data Studio. Now the new name is Looker Studio. There's a free version that is available, and it means that Looker Studio is the visualization front end on BigQuery. So you will have Looker Studio here, and the back end you will have Looker Studio will be here, and the back end you will have the BigQuery. And you have your data repository here. And three of these so your raw data, it get processed through BigQuery, and then Looker Studio is the one where you can look into that. Now, here we combine Looker with Big Studio to create these dynamic dashboards. And you can integrate insights into the daily workflow. Sometimes you need those dashboards to create online online dashboards that can tell you what's going on in different parts of the world or in real time in the case of financial systems. So uh, now let's talk about the AI and ML fundamentals. As you know that artificial intelligence the artificial intelligence is almost like simulating human intelligence. It is more fictional. It's more theoretical. It's more what than how. You know, AI is that we think that machines should have that wisdom, but we don't tell that how we are going to implement those algorithms to provide that wisdom. Machine learning is ML is more how. So it means that AI is the requirement part of it, the expectations that we have, and machine learning is actually the algorithms that implement those expectations. And one way of describing these two, the relationship between these two is AI is like this. This is the bigger circle that we have. This is what we think that machines can do. This is what we think that machines should do. And with all its imperfections, we are able to achieve some of those things, and that is called machine learning, ML. So ML is in the inner circle, and now these are about those 50 algorithms that are in my book as well that essentially implement those the actually the how part, how you are going to meet those requirements. Now, if you look into the business value of machine learning, because machine learning allows you to fully get maximum out of the data that is there. It allows you to create those predictive architectures. It allows you to create those prescriptive analytics, give prescription to your problem. And machine learning, it's about classification, regression, clustering, natural language processing, computer vision. All of these are different algorithms, different parts that cover one aspect of the problem. And now these are the algorithms, but the business value of that is that it allows you to unlock the information in your unstructured data and structured data as well. You know, so now the problem with AI and ML is that there are a couple of problems that are there. First problem that is there with the AI and ML is that the need that we have, the processing needs are very different in when you are training the model and when you put the model in production. When you're training the model, the processing needs are huge. You need to have lots of processing power in order to train the model. And once the model is trained, it is deployed, then it's a teeny tiny file. You don't need that much processing power. You know, so it means that the mismatch between the requirements that we have in the training and inference times, that is always a problem for on-premise infrastructure. How much resources, how much computers, how much nodes should you buy? Because once the training is over, if the training takes 6 months to get the model ready, once the model is deployed, then what you will do with those 100 or 60 or 70 computers that you bought? So cloud provides you a perfect solution for this by providing you with elastic infrastructures. It's a perfect solution because cloud inherently is a elastic infrastructure. So that is why elasticity of the cloud It goes a long way in creating solutions that are cost effective, in creating solutions that are performant. We are always looking for best of the two worlds. We are always looking for the solutions that are performant as well as cost effective, not the other way around. We want sort of Ferrari at the cost of Toyota Corolla. We want something that is performant, that is fast and cheap at the same time. And cloud is one of those infrastructures that allows you to create those solutions that are cheap and that are performant. Now, and in machine learning, this is one of the fundamental requirements, that we want solutions that are performant as well as they are uh, they are cost effective. Now, when we talk about AutoML, if your team do not have much expertise of creating the training the model, then we have something that is called AutoML. AutoML is the push button solution to train the model. You just push the button and the model will be trained in a couple of hours. The downside of it is that it is good for a start, it is good for a pilot project, but it won't be able to create solutions that are domain specific. If you are working in financial domain, if you're working in let's say in healthcare, if you're in government, then the specific, the nitty-gritty details, it won't be able to pick this up. It will just treat everything in a generic manner, but it's a push button solution. And you can also create a custom model. Now, the custom model that we have, now the custom models are where you have those you can customize it according to the domains, need of the domains that you have, and now you choose whether you choose AutoML and or whether you choose custom model. It depends on first of all the of course the need, but it also depends on sometimes you are just trying an idea. In that case, AutoML should be good. Now, if you are looking for so these are terms that we have. Virtual machines. If you want to look into virtual machines, we have compute engine. If you want to look into containers, then there are containers are available in Google Cloud. There are different packages, apps. If, for example, you create the Google Managed Notebooks, it's based on containers. They are, let's define some other terms there, microservices. Microservices are, it's one of the design patterns where the services that you want to create, it tries to solve only one problem at a time. So they are, so your solution actually is an orchestration of those services. And the example would be that if you're looking for pizza card delivery, so in that case, what you will have is that your system that you have on it will be sort of orchestration of different services. That is your catalog that you might have, or so for example, if you're looking for a solution for pizza delivery, in that case, you can choose to have, for example, cash payment. You can have sort of a catalog where you can choose what sort of pizza do you want. You can have order tracking. And other services there as well. So now this is microservices where is a philosophy. We build the solutions that are actually an orchestration. So this solution, what you have is that this pizza delivery, instead of creating one monolithic application, you divide that into
a bunch of, these are three, it may be 10 of them, and each of them are developed independent of each other. Now, um, uh, we in Google, we also have something that is called preemptible VMs. Now, preemptible VMs are that when you are choosing your virtual machines, uh, you can get virtual machines at only 10% of the price. Instead of paying $100, you are paying only $10. What's the catch? The catch is that these are the machines that Google has built in for additional capacity. Google as a company, they want to make sure that they have extra machines available for unexpected high traffic. So they have those machines and they are looking to monetize that. So they offer those machines to you for only fraction of a cost, 10% of the cost. But the fine prints are that if Google need them, they can take it away. So it means that now they are called preemptible machines. This is the concept of these preemptible machines that we have. So these preemptible machines that you have, they can be used to not as the primary machines that you have, but to build the additional capacity. You have 10 nodes, they're doing their jobs, but okay, preemptive machines, they are so cheap, you can make them 12. And if Google take them back, so you design your system in a way that failure of any node should not affect, they should be redundant. They should be doing, there should be redundancy that your system should, if Google take it back, usually they don't take it back, but if they take it back, it just slows down the things just a bit. They are called preemptible machines. Now, if you look into the load balancing, now load balancing is a challenging concept. Whenever you have more than one nodes, it's like you're a manager trying to assign jobs to different team members in a way that everyone is busy. So cloud as a system, it has managers that are trying to do the same thing. They're trying to make sure that all the nodes, they're kept busy, and node balancer is the one that tries to balance the load among all the resources, all the computing resources that you have. And so that is called load balancing. And then there is auto scaling. Auto scaling means that when the rush hour comes, the system automatically provision more resources. And there are two flavors of it. One is predictive and one is reactive. Predictive autoscaling is that it learns, it is more complex. It learns that there is a rush hour that comes from 12 to 2 each day. So it will be ready for it. It will scale up in preparing for that rush hour. And then there is, so that is predictive. The reactive is that it's a firefighting mode. Once the rush hour comes in, then you react. The system reacts. It's simpler to implement. So they can be predictive and they can be reactive, but these are, and then they are load. Now, load balancing, auto scaling, both of them, we talked about the sophisticated infrastructure, level 3 of maturity. Level 3 of the maturity is when the cost is down and the performance is up. If the cost is down and the performance is up, we have a Ferrari at the cost of Toyota Corolla, and that is our end goal. So we always try to create the goal of all these techniques is to keep the cost down and keep the performance up, still keeping the same availability, same reliability, same security, but cost and performance, they are going in two separate directions, and we are picking our battles so that we win this war, that the cost remains down and the performance remains up. And load balancing and the auto scaling, these are two most powerful technologies that we have that can help us achieving this, right? So these are our most both of them. Both of them goes a long way in bringing the cost down and performance up. Now, serverless computing already defined that. What is serverless computing? That is our BigQuery and how we use that. Now, containers. Now, you use containers in the cloud as well because containers provide you the right level of abstraction. So we talked about cloud native architectures, and lift and shift. Now lift and shift containers is the best way we can enable multi-cloud environment. Because if your solutions are containerized, you can just copy the container from Google to AWS and from AWS to Azure, and nothing should change. And if you extend that idea to on-premise to the cloud, then it can also enable lift and shift. So containers enables you two things. First thing is they allows you to break the vendor lock-in. And the second thing is that it allows you to do lift and shift. So if you use containerized systems, your vendor lock-in is broken. There is no vendor lock-in, and your lift and shift, it enables lift and shift, right? And that is why containerized systems, these are a powerful tool that we have. Because when the vendor lock-in is broken, it enables multi-cloud environments. It enables it itself. If you look into this, once the vendor lock-in is broken, it allows you multi-cloud that we talked about. And when the vendor lock-in is broken, it also means that you can even move to on-premise if you want. It's all you need is a environment that runs the cloud, right? So this is the orchestration of these containers that becomes important, and the orchestrator that we have for these containers, that is called Kubernetes GKE. That is the orchestrator. Now, Cloud Run, it's an orchestrator. This is the next version of GKE. It is a newer product that we have, and what it offers you is that instead of managing the nitty-gritty, the maintenance of GKE, it's Cloud Run. You just run that in a managed serverless fashion. So as the number of APIs grow, then the need to manage them as well. So Apache API management system is there. They allow you to secure, monitor, analyze APIs, make sure that they are managed in the proper way. As we are creating those microservices, they depend on APIs, because each of the solution that we create, this is exposed as an API. And now we talked about the different types of clouds, the hybrid and multi-cloud. Now it depends on which one are you using, but there is a product that we have that is called Anthos. Anthos enables multi-cloud systems. Now, trust and security in the cloud. Now there are more and more cybersecurity threats around us. Phishing, ransom, denial of service attacks. And now for that, we have an acronym that is called CIA. CIA stands for confidentiality, integrity, and availability. Whatever solutions that we have, it should have confidential data, it should have data integrity, and the system should be available. So now these three things: confidentiality, integrity, and availability. Why availability is here? Because if you bring the system, if you take it offline, then there's no threat. That's why, so you need to create solutions that are available. It's not that if you sense the threat, you take it offline. That's not on the table. We need to make sure that while being available, it is implementing confidentiality, it is implementing integrity, and so these are the requirements that we have. Now, if you have visited any castle, and a medieval castle in, for example, in Europe or in India, or you must have seen that the defense of that castle is done in different layers. There will be a huge door, and then there will be sometimes there will be 3 or 4 different layers of defense. Uh, they have dug down the earth, and then there will be different layers of defense that are there. So in cloud, what we do is that we do not put all the eggs in the same basket. What we do is that we create multiple layers of security. Depth in defense is we have both in the physical and network level. And we also, what we do is that we want to make sure that the data is encrypted both in rest and in use. And these days, we always encourage to enable multi-factor authentication. That combines with our authentication and authorization module. Authentication is it's called IAM, authentication and authorization module, identity and access management. The identity is the authentication part, and access management is the authorization part. Cloud Armor is there. This is used for depth of defense. It is sort of a firewall that detects it. There's intelligence built into Cloud Armor. It makes sure that our systems, they are defended against. It senses, and it has a turtle mode where it just like a turtle. When turtle senses some danger, it brings the neck in its shell. Same thing happens here. Now, if you want to look into the Google's trust principles and compliance, so we talked about the shared responsibility for protection. There's something that is your responsibility, and then there is something that is vendors, that is the Google's responsibility. And there are so Google follows the industrial standards. ISO, SOC, all of them, they are fully implemented and they are fully followed as well. Now, if you look into the financial governance, so it is important that when we say that the cost should be minimized and the performance should be high, cost should be monitored as well. So it is a best practice to create a budget and alerts as well. We do not want any rogue actor or rogue process to just start costing too much money. So we want to keep an eye on there, and that's why we have multiple layers of so you can build quotas. There is a resource hierarchy. There are organizations have folders have projects, and projects have different resources. So the cost center is here. Our project is the cost center. So these alerts that you will be created, budgets will be created, they will be created at the project level right here. Now, what we do is that we have, it's important to first define budgets. What is the budget? And it's not enough to just define quotas and shut things down when those quotas are exceeded. Because what might happen is that, let's say that it's the middle of the month, the quotas are exceeded, then you won't have that service available. So you need to keep in track on where that is being spent. And you also need to be aware of there are committed use discounts. If you commit to a service for 2-3 years, there's a big savings that you should be aware and of that. Now, CI/CD delivery, the continuous integration, continuous delivery. There are lots of tools that are available in Google Cloud. Now, CI/CD, this is always tricky to implement. The dream is that as developers are writing something, it goes through integration, it goes through integration testing. Now, this goes towards our production environment, it's tested there, then it's continuously and developed and deployed as well. Now, is easy said than done. It also depends on what light of business you are dealing with. But CI/CD pipelines, they need to be elastic pipelines. They need to be dependable pipelines, and there are different tools that are available to realize these CI/CD pipelines. So there's Google support is there as well. Yeah. Now, if you look into the key takeaways, now Google's role is in digital transformation because Google has the processing power, and it is offered as a service. You can subscribe to a service, and that is the catalyst for innovation because you can try out different ideas, and if they work, you keep going in that direction. Otherwise, you can change your choices. So it means that. So first of all, Google has a role in digital transformation. Second thing is that it enables data-driven insights. Data-driven insights. There are two parts of it. First part is we process the data. That is where BigQuery comes in. So in data processing, what we have is that we have BigQuery. This is a processing part of it, and then comes the visualization part of it, and Looker provides you with that capability, and together it gives you data-driven insights, those dashboards that allows you to see that what's going on across your problem domain. So there are different machine learning solutions that are available. In that case, you have AutoML. That is, you can use that as the push button machine learning solution. You push the button, it should process and train the model. Vertex AI is the single window operation that we have to train the model. You can have the custom models that you have. You will develop that within the service that are available in Vertex AI. And if you're looking into infrastructure modernization, in that case, you can choose infrastructure as a service. In that case, you will choose compute engine. If you want to use platform as a service, in that case, you will use service environment. I give you the example of BigQuery. You can use containers. Anthos allows you, it enables you multi-cloud environment by providing you multi-cloud container orchestrators. It means that your container, Anthos makes it irrelevant that you are running it on Google Cloud or in AWS or on Azure. So Anthos is your tool that is an enabler for multi-cloud environment. So Google, first of all, encourages you to take a look at shared responsibility model. Realize that what is your responsibility, and realize that what is the responsibility of the vendor. And it also allows you to make sure that you are aware of the best practices that are there to build the right solutions that are secure. And then whatever we are talking about, it should be done in a way that we are not unnecessarily using resources both at our end, and this also applies. Google as a vendor is committed to provide solutions that okay.
Thank you, Imran. That was very informative.
Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and
webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So we, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Now, next up, we are offering Google Cloud Fundamentals course, which is usually priced at $575, but we are offering this absolutely free of cost. So this is the full one-day course in which you and your teams will learn how to use Google Cloud services and tools effectively and gain a solid understanding of the core components of Google Cloud platforms. You will also get hands-on practice through practical labs, allowing you to apply your new skills right away. So this is a full day course, unlike our master classes and webinars. So we have limited seats available for this, and you can request enrollment by clicking here on this button. So submit your registrations to us as soon as possible, and our team will get back to you with the confirmations. Uh, Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla.
And now we're going to go ahead and jump right into our question and answer session.
How has the concept of digital transformation impacted your organization, and what challenges are you facing in adopting cloud technologies?
Now, first of all, when you move towards the cloud, that's a good question. When you move to the cloud, I said that we are always trying to create solutions that are cost effective and that are performant. That are we are always looking for something that is powerful and cost effective. But what happens is that when you are moving towards digital transformation, you sometimes the organization does not have the in-depth knowledge of the cloud. So they choose the components, the infrastructure structure that is simplest, that meets the functional requirements. Functional requirement, it means that things will work. If it's a fraud detection system on premise, it will do the fraud detection in cloud, but it will not meet the non-functional requirements. If you want, if you may not implement the elasticity, you may not implement the auto scaling, you may not implement the load balancing because you are in a hurry or you want to meet the functional requirements. In the long run, it won't be cost effective. You know, if you want to build cost-effective and performant solutions, then it means that you need to have full knowledge before you design the whole thing. And that is the challenge, because when organizations are moving to the if you, they to the cloud in the first go, it's almost a catch 22. That you need full knowledge in order to create a full solutions. And the remedy of that is that start with pilot projects, that will set the expectations, try out ideas before going full-fledged.
Which benefit of cloud computing, scalability, cost savings, or agility do you find most compelling, and why?
So my background is in machine learning. I have a PhD in machine learning. I have in my line of business, the work that we are doing, elasticity is very important, because when you're training the model for those 2, 3, 4, 5 hours, we need sometimes 2,000 nodes. Otherwise, it will take too much time, right? So cloud is the only infrastructure that can allow me to train those very complex models. Without cloud, I will simplify my models, and it will just create something that is not that useful. So in computing, for me, in my line of business, scalability is a game changer. This is what allows me to create solutions that can attempt at solving some really complex problems.
When considering migration, what are some concerns or hesitations your team has around moving existing workloads to the cloud?
So when you are moving to the cloud migration, you have to choose between two things. We talked about whether it should be lift and shift approach or whether it should be cloud native approach. Lift and shift approach is that you choose a component that is almost exact match. If you are using of whatever you are on premise, you have to refactor. You know, it means that you don't have to rewrite. You don't have to invest any energy or any resources rewriting the code. Day one, it should run on the cloud, but you are not taking the full potential of the cloud. You're not taking advantage of the full potential of the cloud. On the other hand, if you choose cloud native, then of course you are taking, because it's a component, it's a service that is written for the cloud. It can take, it can squeeze out full power of the cloud, but it's not lift and shift. This is one thing. The second thing is that this is the choice of cloud native and and lift and shift. And the second thing I would say is that testing everything. Once you move to the cloud, sometimes you need to before you decommission your on-premise. So the full test, because on-premise sometimes you don't have need to have that comprehensive testing. So once you move to the cloud, before you do decommission, so that is a challenge. You need to think it through, that how you're going to test it, that yes, this is the 100% replacement of your on-premise infrastructure. So
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience, as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.